Next up, we have Jecelyn, and she's going to talk about browser automation. So she works at Google Chrome, at Google, on Google Chrome, on the Google Chrome DevTools, which is something that I use every day, and I thank God for existing. And she's going to talk how browser automation works, why is it so hard for all of us, and apparently some new things that we'll find out. Yeah. So thank you so much.
Okay, hi everyone. Nice to be in London for the rain. Oh, okay. Okay, so this is a little bit about myself. So I'm Jecelyn. I work in, so you might have seen my face before if you did not close the What's New tab in the DevTools. So from time to time, if it pop up, you click on it, not the close. You'll see my video or my articles talking about some new stuff every month. And I also do some DevTools tips video to tell some tips that you might help to improve your productivity in DevTools. So I work specifically on the Chrome DevTools team and the browser automations team. So if you use Puppeteer, these are part of the project in my team as well. So other than that, we have Chrome driver and WebDriver BiDi, which we'll talk about slightly today. So let me start by sharing my test automation experience in real life. So this is me. So when I try to write a test automation script, sometimes I just feel like, oh, why it doesn't work? Every time when I test it manually, it works. But when I automate it, some line might go wrong. And even worse, that when I start to run the script, sometimes it might get really slow. In my laptop, like sometimes my laptop is from M1 become F1 because it's like really loud. And even sadly, sometimes the test can only run in certain browsers. For example, we probably can't test, if you are writing with certain test framework, you can only run tests in Chrome browser, but not others. So to understand why all this pain happening, we need to first, so this talk will log into the past, on some history on test automation, and then we talk about the current time, what are the current browser automations approach and what is the limitations. And we'll share about the futures WebDriver BiDi and why do we start this project to bring open, fast, and cross-browser automations protocol. Okay, let's travel back to 3 decades of web and automations. So the web born in the 90s. Okay, I guess everyone used that before, maybe not that 2 browsers. And Java also started around the same time. And at this point of time, no one thought about test automation because the web was meant to be browsing like just documents. So no one thought about test automation. Basically, in this era, we just do manual tests most of the time. And then in 2000, the next 10 years, we have more browsers joining the scene. And the web become more interactive. We use Web 2.0 for social media, and you have jQuery, Google Maps, YouTube, which bring like really interactive experience using JavaScript. And we have new mobile phone coming up as well. So now, as a person who develop web applications, we need to test not only for multiple browsers, which sometimes things work in this browser, doesn't work in the other browser, and you need to test on different mobile devices as well. So finally, thankfully, there are 2 projects started. We have Selenium and WebDriver, which to try to tackle these test automation challenges. And shortly in 2009, that's when NPM Health started. No, that's when Node.js introduced, which brings JavaScript development to the backend. So let's go to the next 10 years here. So Selenium and WebDriver project sort of agree that they merge into a single project called Selenium WebDriver. And oh, where's my line? The line is so soft. Okay, there's actually a line that I draw. Okay, so and then slowly it became really popular, a popular standard. So in 2018, WebDriver became a web standard. So we call it WebDriver Classic. Okay, and then at this time, there's a lot of JavaScript frameworks start booming. And naturally, people also want to start writing test automation script with JavaScript. So we have quite a few libraries and testing framework coming out, which is WebDriver IO, Appium, Protractor, which is deprecated, and Nightwatch. And slowly after that, we have Test Cafe and Cypress joining the scene as well. And then we have Puppeteer and Playwright. Okay, if you look at all these tools, like these 8 tools which are still exist today, the way they do browser automations behind the scenes is not that different. I can categorize it into a high-level approach with the execute JavaScript within the browser, and a low-level approach with the execute remote command outside of the browsers. So for example, Cypress and Test Cafe, they use the System API and Node.js to try to do some automations within the browser. So some of the tests run pretty fast, but there are some limitations, like if you want to open multiple tabs, or if you want to simulate device mode, or if you want to mock the network request, you need to go lower. That's when you need something called a protocol. So we have WebDriver Classic Protocol, and we have Chrome Dev2 Protocol, which is called the CDP. So you have these 2 categories, and Cypress and Test Cafe also use CDP to automate something in the lower level. Okay, so today our focus, I will show you a demo on how this WebDriver Classic Protocol and CDP work behind the scene. Okay, so let's start with WebDriver Classic. So what this does is that your automations tool or your framework will talk to a middleman, which is the browser driver. So it will issue WebDriver command via HTTP request, and the browser driver will control the browser using their internal protocols. So because it's a W3C standard, which means all the major browser will keep the driver up to date. So if you are doing test automation, you have all these drivers that get released every time the browser get released a new version. Okay, let's see this demo. So let's say we have this demo that we want to navigate to a page and click on Espresso. So this might be your script. So this script, I write that in a WebDriver IO library. So you go to a browser, set the window size, go to a URL, and click on the Espresso. So nothing complicated here. And if we go to all this step, all this action, each of these steps is mapped to multiple HTTP command basically behind the scene. So for example, this step, okay, go back. Demo time. Let's see if demo got with me today. Okay, so let's say, so this is the script that I showed you just now. Let me just enable this, this one because we want to debug the session. And I run the script. I'll start a Safari browser. This is not the Chrome browser. Okay, so now we have a session ID. So if I want to change the window size, what I did is that I issue a HTTP command. I don't need to use any code anyway. So I just pass in the session ID just now. So what I did is that I will change the size, let's say, to the width to 1,000. And I run the request. You see that the window size changed instantly. And change it back. So you get the point. So if I want to click on the coffee, I can run the others command and run the other commands again. Okay, let me just close this. Okay. So behind the scene, these are the commands that gets HTTP command that get issues. You navigate to the page, you find the coffee, and you click on the coffee. And every time when you talk to the browser driver will talk to the browsers and bring back the response almost immediately until it is not. So step 2 is slightly tricky behind the scene because it's a HTTP command, so that the browser have no ways, or the automation still have no ways to subscribe to certain event to tell the driver that, hey, please notify me if when the coffee is ready, just pass me back the response because your API call might be really slow. So what it did is that because of the limitation, so it has to use HTTP long polling to keep polling the response, and every time it includes some latency, and that's why sometimes it gets slow. Okay, so in summary, WebDriver Classic has the best cross-browser support. It is a W3C standard. It is built for testing, but it is slightly slower because it's HTTP-based, and it provides only high-level controls. I will talk about the controls in the later of this presentation. So next, let's talk about Chrome DevTools Protocol, CDP. So CDP, this protocol was initially designed for Chrome DevTools. So when Chrome DevTools, you use the Chrome DevTools to inspect your page, behind the scene, you are using CDP. And slowly it evolved because it's so powerful and so speedy, so it's evolved into automation protocol. People use that for test automation. So what CDP does is that your automation tool doesn't talk to a middleman. There's no browser driver. You talk directly to the browser, but only Chromium-based browser. That's why some of your tests only run in certain browsers. Okay, and what it does is that your automation tool issue a CDP command, and then to control the browser via WebSocket, which is a bi-directional communication channel, different from HTTP. So Puppeteer is using CDP under the hood. So let's say you have this code where you navigate to the page and set the viewport and click the coffee. What it does behind the scenes, for this step, is that, I can show you. So if you want to see like what are the CDP commands running behind the scene when you are using Puppeteer, you can add this debug, set this debug variable, then you can see it. I can show you a demo here. So this is my CDP script. If I run it, so I run it with the debug command open. So you can see that it will tell you that what exactly are the protocols, are the CDP command that send behind the scenes. So methods and session ID and other stuff. But if you want to directly use CDP command, you can use Chrome DevTools to do it as well. So a CDP command is basically have a command and have a parameter. So in this case, I create a snippet. I will just copy it first. And what I did is that I can use the protocol monitor tab. So when you open, you can click on this, enable the experiment for protocol monitor, and then you can click this 3 dot to open it. And from here, these are all the commands that's happening behind the scene. So let me just clear it. If I go to like Elements panel, so every step you click might involve a certain CDP command behind the scene. So what I did now is this is a blank page, and I want to navigate to my coffee site. So what I did is that I can send the CDP command, the raw CDP command, and click Enter. It will navigate to the page. So this is how the browser automations happen behind the scene. So, so these are some of the commands that happen behind the scenes. So when you navigate to a page, there's one command. You find the coffee, there's another command. But when you click the coffee, it sort of involves like 2 commands. You need to click, and you need to release the mouse. Okay. So almost immediately, because it's WebSocket based, so the automation tools can subscribe to the event. And when the coffee is ready, it will just send directly back to your automation tool. So this faster, there's no way in between because it's a bidirectional communications. And even better, CDP actually, with CDP, you can have some low-level control, which is not possible when you're using WebDriver Classic because it's HTTP-based. So with CDP, you can intercept the network request. That's why you can mock the network API. You can simulate device mode and geolocation, and you can get console message. Sometimes when you test, you might want to see like what are the console messages that get logged. You want to monitor that. So all this you can do in CDP, but not in WebDriver Classic. But CDP is really fast CDP also really fast, and it provides low level of control. But the bad thing is that it's the Chromium-based, it's only work on Chromium-based browser. It is not a standard outside of Chromium's ecosystem, and it's complex. It has more features, because it's built for debugging. So how can we browsers and the testing ecosystem improve the cross-browser automation fundamentally? So if we combine these benefits of both protocols, that's when we have WebDriver BiDi. It's a new standard of cross-browser automations in the making. So the visions of WebDriver BiDi is that no matter what automations tool that you are using, they can use WebDriver BiDi protocol behind the scene and to automate any browsers or any drivers, depending on the implementation. It is currently work in progress. So who is in this project? So the browsers, vendors, the major browser are collaborate together, and also automations tools and testing provider as well are all join force to come up with, to work with this WebDriver BiDi protocol. Now you might be wondering, what does it take to implement a new protocol? It is a huge effort, it takes a lot of works. So the first step is that there is a spec, which you can go to this link. There's a spec and a request for feedback session, so everyone can put in and mention their concerns and talk about the implementation details. And the second part is verifications. So there will be a set of tests written in Python that can run across all the browsers, because we need to make sure that the behavior is standard in all the browsers. So there's a set of tests as well. And finally, we have the implementations, which you can track the progress in this dashboard. So I take a screenshot on the current progress. It's pretty good. Safari have some works as well, so there's one there. So it's not bad, but if you want to see the latest result, you can also like scan this to run that. Okay, so I mentioned that it's work in progress, but the good news is some of the initial support already landed in these tools. I can show you some example now. So let's say we use the same example just now, and we want to catch the console error, because when you click on the coffee, sometimes it's not just the click, you call some API behind the scene, or you call some A/B testing or analytic API, that might fail. Not the clicking process, but that might fail. So you want to make sure that you want to capture like any JavaScript exception in the console and throw an error if it is. So go back to my script just now. During the setup browser time, what you have to do is you have to pass in this WebSocket URL, set it to true. That's how you enable the WebDriver BiDi features in WebDriver IO library. So after that, you can use that. You can set the browsers to Chrome, or you can use Safari to do so. And then the next step is that you want to start monitoring the log. So you need to first subscribe to the sessions and subscribe to the log event. And second, you want to handle the event. So in this case, when there are message, what I did here is that I will just assert it and throw fail, because we expect the console is clear. So if I run that in Safari, this is like Firefox browser. This is the result. So you see that you scroll up, we see that there is an exceptions message get thrown in there. And the good news is WebDriver BiDi is to enable the WebDriver Classic to have low-level control and monitor console message to verify uncaught exceptions, and intended log is just the first step. There's many more coming, and we have the roadmap sharing here, so you can see that what are the new capability it will unlock soon. And the good thing is that just now the script, basically I'm using the same script to run it. So WebDriver Classic interoperates with the WebDriver BiDi. So it's not that you need to switch and use a totally new protocol, but you can add the new features on top of it. So if you are testing with the browser that supported WebDriver BiDi now, you can just add the console monitoring features on top of your previous script. You don't need to write a new script or new stuff to do it. And Puppeteer also support it, because I thought I do not have like enough time, so I did not plan a demo on that, but I can run that because I have 6 minutes, so let's do it. Okay, so this is unplanned demo, so if it doesn't work, let me open Let me just clear it. PPTR BiDi. So almost similar in the web. Let me just enlarge this one. So if you launch Puppeteer with the setting the protocols to WebDriver BiDi, when you run the page monitoring the log, it is using the WebDriver BiDi instead of the CDP. So if I run this, you can see that, okay. Oh no, too big. Okay, you can see that, yeah. You can see that I'm using Headless, and I received that there's a message log here. So it's the similar effect. Okay, so in summary, WebDriver BiDi is an open standard, it's cross-browser, it is faster, and it's built for testing, not for debugging. So if you want to learn more, you can go to this blog post to read about it. And if you want to support the project, there's 4 ways to do it. So my colleague told me that, so I asked him, like, oh, so how can I make my slide more interactive? And then I said, change this slide to a Buddha hand. So that's how I get it. So first, you can test and adopt it, be the early tester and adopt it. And you can ask for BiDi support. So for your favorite test automation framework, you can file an issues in their repo or just talk to the DevRel and the team, like, do they have any plan to support it? And you can share this slide or other slide, or me, or the slide, and hashtag WebDriver BiDi to share about it. And you can learn more and understand more on the spec. And okay, one last thing, but actually 2, because I'm not Steve Jobs, so I'm going to take 2 things. Recently, we upgrade Chrome Headless mode. So previously, so the history is that Chrome support Headless mode for a really long time, like when you run Puppeteer, behind the scene, you are using Headless mode. But there is not the real Headless mode. So you might thought that, oh, it's just hide the UI and do not use the UI. But previously, it's basically like 2 different types of implementation. So when you run Headful mode, it's one implementation. When you run Headless, it's the other implementation. Now, we say that it's too much maintenance. We combine it, and it helps you, if you are testing your Chrome extension using previously, it's really hard to do so because there's no way, because there's like different implementation. Now, we bring them closer using the same source code. So we introduce a new Headless mode. If you run it, you just run this -- Headless new. To run it, you can read more about that on the use case that you can unlock in this post. And just now, when you can also use the recorder panel within DevTools to record your step on the screen and export it to any script that you like. For example, we support Cypress as well. I still have 2 minutes. Okay. Let me show the recorder. Okay. So if I go to the Coffee app, I can open the recorder panel. Let me just close this. I can say that order coffee. What I can do is I can click on the coffee, click on the total, set the name. Oh, okay, I need my email as well. That's not my real email. And I submit, and I click stop. So you can record. So all your step is record on the screen. So you can replay it, and you can pick like different split, like slow, very slow, to replay it. Or you can step breakpoint at the step, and when you click replay, it will just stop at the step, and you can run it step recorder. And you can run it like step by step. Okay, let me just run it all. Yeah, to execute the script. But what is even better is that we have this show code features, and you can install some extension to export it to Cypress, Nightwatch, WebDriver IO, testing library, and web page test. So this is what you can do. You can download the script to others format or Puppeteer as well. So check it out. Just open the browser and give it a try. Okay, 1 minute. Cool. Eh? Okay, slideshow. Okay, so that's all for my talk today. You can get the whole slide using this link. So it's a form. You can just download the link. But if you want to be nice, you can fill in the form and tell me like what is interesting about this talk. Do you learn something new? And what are the automation framework are you using? And what are the pain points? Okay, that's all. You can follow me on Twitter as well. And Mastodon, thank you.